Okay, Passerians, this video is 1.8c, combining functions. Today we're going to talk about the composition of functions, and we're looking at two functions, f of x and g of x, and this notation is pretty weird. It looks like a multiplication sign, but it's not. This means f of g. So this little thing here is basically saying f of g of x. And obviously, likewise, this is saying g of f of x. The little thing looks like an O, so I always think of it f o g, you know? So f of g. And this is saying g of f of negative 2. So those are the things we want to find, basically. So what we do is we want to take g of x, we'll make it blue, okay? And we want to plug that into f of x, which we'll make, I guess, red. Okay, so we'll take this and we'll plug it in for x. So f of g of x is 4 minus x squared. That's the x value. And then plus 2. And that should be our answer. Let's put it in a nice little box. Okay, so all we're doing is replacing the x value with the whole function. We're putting the whole function in for the x value. If you remember doing the difference quotient, we kind of did something like this where we had to put x plus h in, right? So we're putting an expression in instead of a number or just a variable. Does that make sense? You start by putting numbers in, get numbers out, then you put an x in, or you put an a in, or you put a t in, get a expression out, and now you're putting like a whole bunch of stuff, you know, a whole mess in there. So g of f of x, we're going to take f of x and put it in for x on g. So that's going to be 4 minus whatever squared. And the whatever is x minus 2, or x plus 2, sorry. And that is our answer for g of f of x. And then this next one is g of f of negative 2. So we would put negative 2 into f, which actually gives us 0. We'd square it, and we'd take that from 4. So if you want to, we can just kind of write down this function, 4 minus negative 2 plus 2 squared. It's basically what we just did. And that's going to be 4 minus 0 squared. That's going to be just 4. So that's composition of functions. So just to get a little bit used to it, why don't you try the checkpoint? They probably go pretty quickly. So you have f of g of x at the bottom there, g of f of x, and then f of g of negative a half. Okay, so pause the video and give those a try. Okay, so hopefully you paused the video and tried these. I'm just going to read you the answers. So the first one was 8x squared plus 7. 8x squared plus 7. The next one was, they're putting them into standard form, so they're like multiplying them out. 16x squared plus 80x plus 101. Not to say that you have to do that, but they're just, you know, simplifying them. And then the last one, the number, we all should have just 9. Okay? So I'm going to assume that those are all right. You could simplify them if you needed to. You might not have. That's okay. But just remember that, you know, the answers will usually be simplified. That's one of the reasons we check our answers in the back, because they simplify, and it helps us to know like whether we should simplify or we shouldn't. And they tend to simplify. So it's good for us to do that. Okay, so now we're going to try to find the domain of f of g of x. And this is a little tricky. I need to like kind of refresh on it myself before today. So what we need to do is we need to figure out, if you think about it, we're kind of starting at the inside, right? And then we're plugging that into the outside. Does that make sense? So we're kind of starting with g of x. Let's see if g of x has any problems. So I'm just going to start by talking about domains. Any polynomial, that means like you have numbers or fractions with integer exponents. So that's a x squared, any x cubed, any x to the 5th, any x to the 9th. All polynomials are beautiful and continuous, and their domain is everything. So I can automatically say that f of x is fine. But g of x is what we want to focus on because that's going to go into f of x, right? So we'll have some problems, I think, if we're not careful. So let's look at g of x and see what issues we have. Well, we know that 9 minus x squared has to be greater than or equal to 0, right? I get a little sketched out using the quadratic inequalities that they call this, because it's squared. It sketches me out. So let's just for a minute, just because it makes me feel better, I'm just going to set it equal to 0. But this is what I know. It has to be bigger than 0, right? So that means that x squared, that means that x squared must equal 9, and x must equal plus or minus 3. So those are numbers that kind of matter. So let's just kind of like do our little number line thing. I always think that kind of helps a little bit to visualize. These are the numbers that are actually okay because you can take the square root of 0, right? That's why those are checks. You can't divide by 0, but you can take the square root of 0. So in this case, we can take the square root of those numbers. If you plug in a 1, it's actually okay. Like these are all good. This is part of the domain. If you plug in a 4, it's not good, so we don't want that. And if you plug in a negative 4 or like a negative 10, also not good, right? Not good. Okay. So the domain of G right away, the domain of G is from negative 3 to 3, correct? Now my question is, are any of those values that come out of G, and I'm talking about the outputs of G, I'm not talking about the inputs, I'm talking about the outputs of G. Are any of those outputs of G going to cause a problem in F? Yes? That's another way to look at it too. That's fine, yeah. You want to be careful of it, of course, because if you cancel out the square root, then you don't restrict your domain. Does that make sense? You know what I'm saying? So if you did plug them in, you might say the domain's all real numbers. But the domain isn't all real numbers. It's only the values in the domain of G that also show up in F. But it's actually the y's of the G of x. But the cool thing is, the good news is, we put a check mark on f of x, right? So any number can go into f of x. So all of the answers, which is the outputs, the y's, for g of x, all of those answers are going to be fine in f of x. So the only problems that we're going to have is any numbers that are not in the domain of G. I know that sounds like I'm speaking a different language, but the domain of this whole thing, the domain of this function right here, is simply negative 3 to 3. Here's what gets a little insane, just if you want to, like, you know, really stretch your mind. The domain is the x values, and when you put them into G, they become y values, and now you're putting y values into f, but you're treating them like they're x values. You see what I'm saying? It's kind of insane. And this is one of the reasons we use function notation, because what's a y and what's an x? You know what I'm saying? It gets all shuffled around. All right, so let's just practice these a little bit. I would encourage you to pause the video and give these a try. I'll probably go over them as well. So they're looking for the domain of f of g of x. This one's a little more annoying, I think. It's not too bad. But if you know the domain of g of x and the domain of f of x, that gives you a good place to start. So pause the video, give it a try. I will go over it in just a minute. Okay, so again, hopefully you paused the video and tried this. We are trying to figure out the domain of f of g of x. So what we're going to do is we're going to look at g of x, which is a polynomial. Okay, a polynomial is anything with like a integer exponent, right? Just integer exponents all in a chain, a bunch of them. And that means that, boom, it's great. Just so you know, every polynomial's domain is going to be negative infinity to infinity. Now, not every polynomial's range is going to be that. So we should probably think about what numbers come out of this polynomial. And this is where it gets really confusing. What numbers come out of this polynomial? What's the range of this thing? How low can this polynomial go? I know I kind of contradicted this earlier. Yes. Exactly. So this range is 4 to infinity. So we just want to kind of like think about that, okay? It's definitely a lot of thinking. And if I come up with a better technique, I'll maybe look at different techniques later, but generally I just kind of like power through these. So any number can go in, so all the x's are in play. It's all good, but f of x is the square root of x, and we can't have any negatives, right? Are any negatives coming out? Are any negatives coming out of the blue function? No. So since no negatives are coming out of the blue function, we shouldn't have any problems with f of x, correct? Because we can't get an output. We can't get a negative from this, which is the range, to plug into there. So we're never going to have that issue. So the domain is still just going to be negative infinity to infinity. So the domain of this is still going to be negative infinity to infinity. Okay. Interesting, isn't it? Because you wouldn't have thought that because of the square root. So there's a lot to kind of think about with that. Okay. So that was example 6, right? Is that example 6? Yeah, all real numbers. Good. I had to check it for confidence, but there we go. Do you have any questions about that? Because people watching this video might also have that question, and other people in class. Do you see what's weird about it at least? Yes? You would have thought that the domain wouldn't be all real numbers, because f of x domain isn't all real numbers. But it's because it's the y's. So you have to pay attention to domain and range of the inner function especially. All right, well, you'll have fun trying it, and hopefully you'll get better with time. Okay, next we're going to talk about decomposing a function. Whenever you see this symbol in this class, it's basically a super important skill for calculus. So that is a calculus symbol right there. And so they just load up precalculus with calculus stuff, obviously, on purpose. And what we're trying to do is just break this into two functions. It's actually not too difficult. We just need to break it into two functions. So this is the answers. They're already there. So what they're saying is, why don't you consider this right here, the inner function, and why don't you consider this right here, the outer function? Does that make sense? So it's almost like something was squared. It's 1 over something squared. That's the red. And the something is this. You could have probably decomposed it a different way. You could have said it's 1 over x, and the other function is x minus 2 squared. So there's multiple answers. But let's just try some of these. So all I'm doing is I'm splitting it apart instead of putting them together. Do you got me? That's all it is. Don't make it harder than that. I'm just trying to find two things that it could be. Okay, couple ways that you could do this. Couple ways that you could do this, and there's multiple correct answers. Why don't you try to write this as two functions? So what I want you to do is I want you to write, basically I want you to write this as f of g of x, okay? What is g of x? And what is f of x? And yes, there can be multiple solutions. So this is what h of x is. So in other words, I want you to make this into an f of g of x. What could be the inside and what could be the outside, right? What could be the function? So take a minute and try it. There's multiple correct answers. Pause the video and give this problem a shot. All right, so hopefully you tried it, you paused it. There's multiple ways to do it, but most of us are going to look as the inside as inside the square root. So I would say that g of x is 8 minus x. And I would say that f of x is basically all of this stuff, but this is actually just x. So f of x is the cube root of x over 5. That'll work. If you take 8 minus x and plug it into f of x, you'll get the cube root of 8 minus x all over 5. So what you did was just broke it into 2, okay? You split Humpty Dumpty, okay? Does that make sense? That's it. That's all we have. Make sure you smash that like button and subscribe. Tick the notification bell so you don't miss out on any of these, really useful pre-calculus videos and other math videos. And we'll see you in the next video. Peace.